Even the most powerful offensive comes to a halt if supplies fail to reach the soldiers. But what happens when the road simply ends, and ahead lie only narrow Alpine trails? In the 1950s, Austrian engineers created a vehicle weighing just about 600 kilograms that could move confidently where larger and more powerful machines stopped. This was the birth of the Steyr-Puch Haflinger, a product of the engineering tradition shaped by Erich Ledwinka, son of the designer whose engineering ideas significantly influenced the development of Tatra. After World War II, Austria remained under Allied occupation until 1955. Following the signing of the Austrian State Treaty, foreign troops withdrew, and the country declared permanent neutrality while beginning to build its own armed forces. The newly established Austrian Bundesheer urgently needed a vehicle capable of operating in mountainous terrain. The American Willys Jeeps left behind were reliable machines, but their design was not fully suited to narrow Alpine switchbacks and Rocky Mountain trails. The Army required something lighter, more compact, and with maximum off-road capability. The task was assigned to the national manufacturer Steyr-Puch in Graz. The chief engineer of the project was Erich Ledwinka, son of Hans Ledwinka, known for his innovative work with the Czechoslovak company Tatra. The engineering philosophy associated with that school strongly influenced the key design solutions of the Haflinger. At the core of the vehicle was a central tubular backbone chassis. Unlike a traditional ladder frame with side members, this backbone tube provided high torsional rigidity while keeping weight to a minimum. The drivetrain components ran inside the tube, offering additional protection from damage when driving over rocky terrain. The suspension was fully independent, using swing axles. This design allowed for significant vertical wheel travel, around 25 centimeters, helping the vehicle maintain traction on uneven ground. To ensure stability on steep slopes, the engineers kept the center of gravity as low as possible. But how do you combine a low stance with sufficient ground clearance? One of the key solutions was the use of portal axles. Thanks to hub reduction gears, the axle center line sat higher than the wheel center, allowing the vehicle to achieve around 240 millimeters of ground clearance without the need for large wheels, and without raising the center of gravity. The engine was mounted at the rear. It was a two-cylinder, air-cooled flat engine with a displacement of 643 cubic centimeters. The absence of a liquid cooling system reduced the risk of overheating or radiator damage in demanding operating conditions. The Haflinger was equipped with four-wheel drive and the ability to lock both the front and rear differentials. This ensured traction even when only one or two wheels maintained contact with the ground. Despite its modest engine output, roughly 22 to 27 horsepower depending on the version, the Haflinger proved highly effective on steep climbs. Its advantage did not lie in speed, but in its gearing and low overall weight. The dry weight ranged between approximately 600 and 650 kilograms, while payload capacity reached around 500 kilograms. In other words, the vehicle could carry nearly its own weight. Depending on the configuration, the wheelbase varied from about 1.5 to 1.8 meters. Even in its longer version, the Haflinger remained exceptionally compact, allowing it to maneuver along narrow mountain trails. Fuel consumption was typically around 9 liters per 100 kilometers, which was considered economical for a four-wheel drive vehicle of its time. The vehicle was equipped with a manual transmission featuring a low-range gearbox. This significantly increased torque at the wheels during low-speed operation. The short gearing allowed it to move slowly but with strong pulling power. Exactly what was required for steep ascents and rocky terrain. Top speed generally did not exceed 70 to 75 kilometers per hour, but in mountainous environments, this was not a critical factor. Control, traction, and stability were far more important. It was this combination of low weight, low-range gearing, and locking differentials that enabled the compact vehicle to operate, where larger and more powerful machines often struggled. The vehicle was named after the Tyrolean Haflinger horse, a breed known for its ability to work reliably in mountainous terrain. Those same qualities defined the character of the machine. Series production began in 1959 with the Austrian Bundesheer as the first customer. In military service, the Haflinger was used as a light transport platform for communications duties, medical roles, and the transport of light weapon systems. Thanks to its compact dimensions and low weight, the vehicle was well suited to difficult terrain. As a result, a significant number of units were exported, including deliveries to Switzerland, Italy, and Australia. Between 1959 and 1974, approximately 600 vehicles were produced. Over time, it was gradually replaced by the larger and more powerful Pinzgauer. The Steyr-Puch Haflinger was not the most powerful or the fastest military vehicle of its era. Its strength lay elsewhere in a carefully engineered design, low weight, and a precise understanding of the environment it was built for. Today, the Haflinger is valued by collectors and off-road enthusiasts. Owners, clubs exist in several countries, and gatherings are regularly held in the Hafling region. Its low weight, around 600 kilograms, remains one of its defining characteristics. The Haflinger did not become a universal off-road vehicle for every condition. Instead, it stands as an example of how engineering focused on a specific task can outlast trends and changing fashions. If you are interested in stories about vehicles designed for real-world challenges and specific environments, consider supporting the video and subscribing to the channel. There are many more machines ahead that reshaped the way engineers approached mobility.